Hi everybody, welcome back to Intermediate Algebra. Today we are in section 7.2 where we are continuing to talk about rational expressions. And if you were able to get section 7.1 down really well, then section 7.2 is going to be a breeze for you. You're going to love this because multiplying and dividing rational expressions is just one teeny little step beyond simplifying. So our objectives in this section are to multiply rational expressions, be able to find reciprocals for rational expressions, and be able to divide rational expressions. And again, if you liked section 7.1, you're going to love this. So let's get started. Okay, first of all, multiplying rational expressions works the same way as multiplying rational numbers. In other words, multiplying rational expressions is just like multiplying fractions. So if you have two rational expressions, p over q and r over s, then to multiply them, you just do top times top and bottom times bottom. That's exactly the way fraction multiplication works. It's the same thing, just now with variables. And as you saw in the last section, simplifying them is also the same as simplifying regular fractions. So in words, to multiply rational expressions, you just multiply the numerators and multiply the denominators, and that's it. Now, in practice, multiplying rational expressions requires the same skills as simplifying rational expressions. You're not going to feel like you're multiplying at all, because I think when I say the word multiplying, it makes you think of like the FOIL process and distributing and combining like terms and all like that, but it's not going to be that way at all. In order to multiply rational expressions, all you're going to do is completely factor the top and the bottom of each expression and then use the fundamental property of rational expressions to simplify, just like we did in section 7.1. You'll write the product as a single rational expression, so one top, one bottom, but it's okay to leave the numerator and the denominator in factored form. That right there, that is so important. It is okay to leave the numerator and denominator in factored form. That means that we're not going to have to do a lot of distributing and combining terms to get to our final answer. That is fantastic news right there. Okay, just like we did in the last section, let's start out practicing on just regular fractions that don't have any variables. So here we have 3/10 times 5/9. Now what I'm going to do is go ahead and rewrite this problem but in factored form. So the 3 is prime, I can't change that, but 10 is 2 times 5. So I'll write 3 over 5 times 2. And then for the second fraction, 5 is prime, but 9 can be written as 3 times 3. Okay, now we can cross things out. We can cross out any factors that are the same in the top and the bottom. So without writing this all as one big fraction, we know that if we wrote it as one big fraction, we'd have 3 and 5 in the top, and 5 times 2 times 3 times 3 in the bottom. So why bother to write it again just to get rid of that dot? There's no sense in it. We can cross out tops and bottoms here. So I have a 3 in the top and a 3 in the bottom. I'll cross those out. And I have a 5 in the top and a 5 in the bottom, and I'll cross those out. And if I had any other like factors, I would cross those out as well. If I had another 3 here, that would cancel out this 3. See, it doesn't matter where in the top you find it. If you have something that's the same in the top as the bottom, you cross it out. Now, everything is crossed out from the top, but remember there's always an invisible factor of 1. So we still have that in the top, even when we don't have anything else. So now I have 1 in the top and 2 times 3 in the bottom. And 2 times 3 is 6. So this fraction multiplication worked out to 1 over 6. Let's do the same thing here in part B. So I have 6 over x times x squared over 12. Now I know that there's no sense in breaking down the 6 because I see the 12 here, and I know that I can write 12 as 6 times 2. So what I'm going to do is write 6 over x here. And then for x squared, I'll write that as x times x. And for the denominator 12, I'll write that as 6 times 2. And then we'll be able to cancel out the 6's, and we'll be able to cross out this x with this one. And that leaves us with x over 2 as our simplified fraction. So notice that that didn't feel like multiplying at all, did it? It still feels like simplifying because it still is the same thing we were doing in section 7.1 when we were calling it simplifying. Now the problems are more complicated, but what we are doing to the problems is the same. Let's look at example 2. So here we have x plus y over 2x times x squared over x plus y squared. It says multiply. Your first instinct might be to multiply this out using the FOIL method, but that would be the wrong move. Remember, when we are multiplying rational expressions, what we really want to do is reduce. Reduce, reduce, reduce. Okay, so let's write this out in a factored form. So x plus y won't factor and 2x won't factor, so we'll keep those the same. X squared we can write as x times x. And x plus y squared we can write as x plus y times x plus y. Okay, now I have an x plus y in the top and an x plus y in the bottom. I'll cancel those out. And I have this x in the top with this x in the bottom, so I'll cancel those out. And now what's left is x in the top and 2x plus y in the bottom. And that's it. That's our final answer. I do not want you to distribute the 2. You could do it and it would not be wrong, but it's not required, so why bother? Leave it in factored form and that's fine. So this is our final answer here. Okay, here's example 3. And again, it says multiply, write each answer in lowest terms. Okay, now we have x squared plus 3x over x squared minus 3x minus 4 times x squared minus 5x plus 4 over x squared plus 2x minus 3. This all looks very complicated, but remember, what we have to do is factor each one separately and then see what we can cross out. Don't try to think about all 4 at one time. Just do one at a time. So here we have in the top left x squared plus 3x. This is a binomial. It has a GCF of x. That's all we can do is factor out the GCF. So let's do that. We will undistribute that x, and that will leave x plus 3 in the parentheses. In the bottom left, we have a trinomial. That's going to factor into 2 binomials. X squared becomes x times x. Last times last made a negative number, so that tells us that the signs have to be different in the parentheses. And then 4, I believe, is going to have to be 1 times 4 in order to get the middle term that we want. So let's put a minus 4 and a positive 1, and that's going to be the factoring for that, because we can check outer plus inner and make sure that we get our negative 3x there, and we did. So now let's move on to the top right. The top right is a trinomial. That's going to factor into 2 binomials. X squared is x times x. The last times last is a positive, so that tells us these signs have to be the same, and they're both going to have to be the same as the middle term. So they both have to be minus. And then again, to get the middle term to add up to negative 5x, we need to use 4 times 1. Okay, you can check. Outer plus inner would be negative 1x minus 4x. That adds up to negative 5x, so that factoring is correct. And then on the bottom right, that's a trinomial. It's going to factor into 2 binomials. X squared is x times x. The last term is negative. That tells us that these 2 signs must be different. And then to get the 3, our only choice is 3 times 1, but let's arrange it so the 3 is positive and the 1 is negative, so that when we check outer plus inner, we're getting 3x minus 1x. That adds up to positive 2x, so that's the right factoring there. Now let's see what we can cancel out. I noticed that in the top we have an x plus 3, and that has a match in the bottom, so those will cancel out. I also noticed that we have x minus 1 in both top and bottom, so those will cancel out. And I noticed that we have x minus 4 in both top and bottom, so those will cancel out as well. And now all we're left with is x in the top and x plus 1 in the bottom. And so, reminder one more time, we cannot cancel out these last 2 x's because this x in the denominator is not a factor, therefore it is not free to be used in reducing. So this is the final reduced form for this expression. Okay, we're about to move on to division. So let's remember that when we divide fractions, what we're really doing is multiplying by the reciprocal. Remember that to divide by a fraction means to multiply by its reciprocal. So here in example 4, we're not doing any dividing yet, but we're just practicing finding the reciprocal of each of these expressions. So here we have 4p to the third over 9q, and the reciprocal of this just means that the bottom becomes the top and the top becomes the bottom. So the reciprocal is going to be 9q in the top over 4p to the third in the bottom. For part B, we have k squared minus 9 over k squared minus k minus 20. So all they've asked us to do here is find the reciprocal. Both of these expressions could be factored, but they didn't ask us to do that. All they asked us to do is find the reciprocal, so we'll do that. The reciprocal here is going to have k squared minus k minus 20 in the top and k squared minus 9 in the denominator. And that's it. That's how you get a reciprocal. Okay, now we're ready to talk about dividing. So if you have p over q and r over s, as long as r over s is not equal to 0, then division works like this. P over q divided by r over s is the same as p over q times s over r. I hope that you already knew that. To divide by a fraction is to multiply by its reciprocal, and then you just use your multiplication rules. So you would do top times top to get ps, and you would do bottom times bottom to get qr. In words, that just means that to divide one rational expression by another, what you do is you multiply the first one by the reciprocal of the second one. So let's practice here. In example 5, it says divide and write each answer in lowest terms. So we have 5/8 divided by 7/16. So first we will restate this in a multiplication form. Never try to decide what you're going to cross out while it's in division form, because you can't do any crossing out until you're in multiplication form. So first we need to restate this as 5/8 times 16 over 7. And now we can see that 16 over 7 could be written as 8 times 2. So we'll do that. 5 over 8 times 8 times 2 over 7. And the reason we want to do that is because now we can cancel out the 8's, and that leaves us with 5 times 2 in the top, which is 10, and just 7 in the bottom. So our final result here is 10 over 7. Let's do a similar thing for part B. Here we have y over y plus 3 divided by 4y over y plus 5. Now I won't decide what I can cancel out until I see it in multiplication form. So let's do that first. So this one is going to be y over y plus 3 times y plus 5 over 4y. So the first fraction times the reciprocal of the second fraction. All right, now there's nothing we can do about the y plus 3 and the y plus 5. They are not the same, and they cannot be factored to be made the same. But we do have a y in the top and a y in the bottom, so we can go ahead and cross those out. And now that's going to leave us with y plus 5 in the top and 4 times y plus 3 in the bottom. The parentheses are necessary because you don't have them here because you have this big fraction bar, but once you put these together under the same fraction bar, then you do need this parentheses to show that the 4 is being multiplied by the whole binomial. It's not necessary to distribute the 4. You could if you wanted to, but it's totally not necessary, so this is perfectly fine. All right, here's another example. So we have 3m all squared over 2p all to the third divided by 6m to the third over 16p squared. These actually ought to be pretty easy for you because there's no factoring that you have to do first. So really all we have to do is get it in multiplication form, apply our power rule to get rid of these parentheses, and then just go. So first, in the top left, we have 3m squared. So this square is applying to everything in the parentheses. So we're going to have 3 squared and m squared. Now 3 squared is 9. And of course, then we have m squared. In the denominator, this 3 applies to everything in the parentheses. So 2 to the third is 8. And then we have p to the third. All right, now we're going to rewrite this division as multiplication. So all of this times the reciprocal of this. So we're going to have 16p squared in the top and 6m cubed in the bottom. And now let's see what we can do to reduce this. First of all, notice that 9 can be written as 3 times 3. So we're going to have 3 times 3 times m squared. 8 could be written as 2 times 4, but when I look up here with what I have to work with in the top, that can be written as 8 times 2. So I don't see any need to break down the 8, so I just will leave it as 8 times p cubed. Now in the top left, we will write 16 as 8 times 2. So we have 8 times 2 times p squared. And this 6m to the third is going to need to be written as 3 times 2, m to the third. Okay, now we can cancel out a 3. We have a 3 in the top and a 3 in the bottom. We can also cancel out a pair of 2's, and we can also cancel out a pair of 8's. So out of our coefficients, all that's left is this 3. So I'm going to go ahead and copy that down. Now let's start working on our variables. So here I have p squared, and here I have p to the third. So notice that there is a larger power of p in the denominator than there is in the top. If you wrote this out without exponents, you'd have p times p times p in the denominator, but you'd only have p times p in the top. So these 2 p's in the top will cancel out 2 of the p's in the bottom, but there will still be an extra one left over down here. So 3 minus 2 is 1. The leftover p is in the denominator. All right, now let's look at the m's. Same thing with the m's. I have 2 m's in the top, but 3 in the bottom. So these 2 are going to cancel out 2 of these and just leave 1 m in the denominator. And this is our final reduced form, 3 over p times m. Okay, for example 7, again we are dividing. So it says divide and write each answer in lowest terms. So we have x squared minus 4 over this factoring divided by this factoring divided by negative 2x. Before we do any crossing out, let's go ahead and factor this top left. So that's going to become x minus 2 times x plus 2. And the bottom's already factored for us. And let's change this to multiplication form. So we change divide to times, and we flip this second expression. So that's going to give us negative 2x in the top, and then this factoring in the denominator. And now everything's factored, and we're in multiplication form, so now we can start crossing things out. I notice that we have x plus 2's in both top and bottom, so let's go ahead and cancel those out. I also notice that we have x minus 2's in both top and bottom, so let's cancel those out. But the x plus 3's are both in the bottom, so those are not available for crossing out. So what we're left with is negative 2x in the top and x plus 3 times itself in the bottom. So you may as well write x plus 3 squared instead of writing it out twice. But if you really don't like the exponent, you could write it this way without the exponent. And that's it for example 7. Let's do one last example together. So here we have m squared minus 4 over m squared minus 1 divided by 2m squared plus 4m over 1 minus m. So let's get this factored and written in multiplication form, and we'll see what we can do to it. In the top left, notice we have a difference of squares. So that's going to factor into m minus 2 times m plus 2. In the bottom left, we also have another difference of squares. So that's going to factor into m minus 1 times m plus 1. Now we need to change divide to times and flip the second fraction. So that's going to be 1 minus m in the top. And in the bottom, we can factor out a GCF. Notice that both of these terms contain a factor of 2, and they both contain an m. So I'm going to go ahead and factor out a 2m. 2m times m would give us this first term, and 2m times 2 would give us that second term. Notice that if I distribute the 2m, it goes back to that form right there. Okay, let's see what we can do here. First, I notice that we have m plus 2 in both top and bottom, so we'll go ahead and cancel those out. And now I don't see anything else that will cancel out directly, but I do notice that I have 1 minus m here, and I have m minus 1 here. Now you see these are opposites. The only thing that's different is the order of subtraction. I have m minus 1 here, but 1 minus m here. If I could get this to be the same order, then I could cancel these out. And remember, we do have a way to do that. If we factor a -1 out of this, we can change the order. So this will become -1 times m minus 1. Then I can cancel out the m minus 1's. See how that works? I changed the order of subtraction by factoring out a negative, and then I was able to cancel those out because they were the same factor then. Okay, now what have we got left? We have a negative times m minus 2 in the top. No need to distribute that negative. And I have a 2m times m plus 1 in the bottom. No need to distribute that 2m. But the only thing I would suggest is that we don't leave this 1 here. So one thing we might do is just write the expression without the 1 coefficient, because a lot of times MyLabs Plus will kind of fuss. If you leave a 1 as a coefficient, it will tell you that your answer is not simplified. So you could do that. You could also just go ahead and distribute this negative so that you don't need parentheses. And if you do that, you're going to have negative m plus 2, which could be even better written as 2 minus m. Instead of negative m plus 2, you write 2 minus m. But notice I never did distribute in the bottom because it's just not necessary. Now, just as a recap of how we multiply and divide rational expressions, note the operation. If the operation is division, rewrite it in multiplication form. Factor everything in the numerator and the denominator, and then cancel out everything you can cancel out and write it as a single rational expression at the end. There is no need to multiply any factors back together. Leave it in factored form and you're done. All right, that's it. I hope this video has been helpful to you, and good luck, and I'll see you in section 7.3.